Hi, my name is Omar, and today we're going to be talking about the Lewis structure. First of all, what is a Lewis structure? Well, a Lewis structure is the simplest representation of a covalent molecule. It's very convenient though because it helps us keep track of the number of valence electrons and can be used later for more sophisticated visualizations. So how do we go from this formula to a 2D structure? And how do you go from a 2D structure to this 3D representation that gives us much more information? Well, today we're going to be talking about how to find the Lewis structure, and then another day we'll talk about how to go from the Lewis structure to this 3D representation that can help us understand how molecules may interact. There are 4 steps in drawing a Lewis structure. We need to sum the number of valence electrons given to us by the periodic table. We need to identify the central atom, which is normally the least electronegative atom. We need to distribute our electrons, forming our bonds. And finally, we need to check that our molecule satisfies the octet rule, and that's the most stable drawing that we're able to produce. In step 1, we sum our valence electrons. Now, we need to find where each atom resides in the periodic table to know how many valence electrons go with it. Hydrogen, our first atom, is located in the first group. Phosphorus is located in the same group as nitrogen. Now I should probably be tracking these along the way. And so it has 5 valence electrons. Oxygen neighbors nitrogen and has 6 valence electrons. Note that we have 4 oxygen molecules and we have an additional 2 electrons because the overall charge of this molecule is a -2. If I were to sum all of these, I get a total of 32 valence electrons. Excellent job, y'all. Our next step is to identify the central atom. Now, if you recall, electronegativity trends upwards and to the right, with our most electronegative atom being fluorine, I believe. I think that's what it's called. So our least electronegative atom, if you remember from our drawing above, would be hydrogen, right? So is that our central atom? Well, not quite. While hydrogen is the least electronegative, hydrogen has only 1 valence electron and thus can only form 1 bond. So it doesn't make a great candidate for the atom holding everything together. Well, what's our next best option? That would be phosphorus. And so phosphorus will be our central atom. In step number 3, we distribute our electrons. So we need to begin to draw our structure. Phosphorus will be our central atom, and this will be in the center of the structure. Let me just draw these first. I begin putting my outlying atoms. More often than not, hydrogen, if it's present with an oxygen, will be bound to that oxygen. Now I can begin drawing bonds, and recall that each of these bonds takes 2 electrons. And drawing these 5 bonds, I have used 10 electrons, and I distribute the rest of my electrons to the outer atoms. Remember, each atom wants to have 8 electrons interacting with it. So in the case of this oxygen, we have our 1, 2, 3, 4, 5, 6 6 electrons in 3 lone pairs. We have another 2 electrons participating in the bond with the phosphorus, giving us a total of 8 electrons, satisfying the octet rule. But this is not the most stable structure that we can draw. If we recall, each atom also has a charge associated with it that is determined by the number of electrons directly touching that atom. Now, if we recall, oxygen has 6 valence electrons. And if we were to consider this part of the molecule and zoom in real close, we see that there are 1, 2, 3, 4, 5, 6 electrons directly touching this oxygen atom. And so this oxygen atom has no charge since it has the same number of electrons directly touching it as it has valence electrons. If we look at, this isn't my best work, so let me write that a little bit better. If we look at this atom here, we have 1, 2, 3, 4, 5, 6, and 7 electrons directly touching it, giving it a charge of -1, as well as this oxygen here and this oxygen here. The phosphorus in the center has 1, 2, 3, 4 electrons directly touching it, while it wants to have a charge, or it wants to have 5 valence electrons directly touching it, giving it a charge of +1. This isn't the most stable structure. What we can do is we can bring one of these lone pairs down to form a double bond with the phosphorus. If we look now, there are 1, 2, 3, 4, 5, 6 electrons directly touching this oxygen, abolishing the charge, and there are 1, 2, 3, 4, 5 electrons directly touching the phosphorus, leaving it with a neutral charge. And looking at the overall molecule, we can see this does match our formula. HPO4 2-. You can see this 2- comes from these 2 electrons here that bear a -1 charge individually. I hope this example was able to help clear up valence electrons and drawing of a Lewis structure, and I hope to see you all soon again. Alright, thank you so much, and goodbye.